So today we're going to talk about 6.5, which is factoring polynomials. Um, but before we really truly get started on this, go ahead and scroll up and fill out the perfect squares and perfect cubes. This part right here is going to be a good little resource for you moving forward, and make sure that you are able to kind of recognize these things. Perfect squares should seem a little bit easier because you've been working with them a lot, but perfect cubes, they'll get a little easier as we keep going. Okay, so go ahead and pause the video and fill all these out. Okay, I will say that the ones that are used the most would be towards the beginning. You'll see these a lot. Once you get past 6 cubed, it's not used very often, but they can be. So keep that in mind. Okay. So these are numbers that we can use moving forward to help us out to factor. All right, so the first thing that we are going to really focus on is more of a review of factoring, which is numbers 1 through 11. So first thing that we're going to talk about is the greatest common factor. All right, when we do that, that's what we can pull out of everything. So if we look at number 1, I can divide 35 and 60 by 5. And then we have x to the third and x to the fourth. So we can take out an x to the third. And then y to the fourth y, we can just take out one y. Once we do that, we're left with 7y to the third minus 12x as a final answer. Okay? So remember, when you're talking variables, you always do your lowest degree that you see. If there's ever a term that doesn't have any, then you can't pull out that variable. For number 2, we can factor out a 3 because 21, 18, and 24 are all divisible by 3. And then the only other thing that they have in common is 1x. The first one doesn't have a y, so I can't pull out a y. You'd be left with 7x to the third minus 6xy plus 8y squared. The next part is talking about the leading coefficient of 1. This is your 3 terms, right? So these are your t-charts. Okay, some of us on the chapter 5 test struggled with this stuff, so hopefully it's better the second time around. All right, so remember we do first times last, so 1 times -5 is negative 5. Then we need to multiply to that -5 and add to the +4. So it would be 5, -1. Remember, in our denominator, we always put our variable and our a value, and then we write it bottoms up. So we have x plus 5 and x minus 1. The next one is 3 terms, leading coefficient of more than 1. Okay, you do not have to do split middle term. You can, okay, but this is a t-chart as well. So on number 6, first times last gives me 5 times 4, which is 20. And you need to multiply to 20, add to 12. And that would end up being 10 and 2. Now this time, you put your variable and your number in the denominator. And because your number, your a value, is not 1, you need to try to reduce if you can. The left one can reduce to 2 over 1x. Then we write it out. X plus 2, 5x plus 2. So hopefully those felt pretty good. Moving on to number 8 and 9. These are by grouping. And if you do split middle term, okay, that talks about grouping. Those go together. So grouping is any even number above 4. So with these being 4, the second one is 6. But you just split it in half, right? And then we focus on the one on the left. 3x to the third plus 4x squared. We can factor out a GCF of x squared. On the next one, I can divide or factor out negative 25. When you divide that, you get 3x plus 4. At that point, we rewrite 3x plus 4, and then we also would write the outside, which is x squared minus 5. Now, we will talk about x squared minus 25 underneath in numbers 10 and 11, but you should recognize that that's the difference of squares, and you can make that x minus 5, x plus 5. The last one we just talked about it is difference of squares. So again, they have to be perfect squares, and all you do is take the square root of both, so x and 10, and then one's a plus, one's a minus. Doesn't matter what order. So the same thing happens with number 11. Square root of 36 is 6. Square root of 25 is 5. So one is a plus and one is a minus. So hopefully all of these feel like old news to you, right? Because we did just talk about that one of the very first lessons that we had this school year. This next part is all about the new method that we are going to use here, which are the sum and difference of cubes. Okay? If you notice, these are actually pretty much the same thing. All right? The only thing that's really changing is the first and the second sign. Everything else stays the same. So if you notice that you have cubes, so we're talking about like 1, 8, 27, so on, right? What we did on that first page. You can essentially take the square root and you put it as a plus b. So it's very similar to the difference of squares, right? You take the square root. This one you would take the cube root. I misspoke before. Then you use those numbers to fill in the rest. Okay, so that this up here is kind of like a formula that you can use to help you out. Okay, so looking at the first one, okay, we have to think, okay, 125 is what to the third? Well, it's actually 5 to the third power. Okay, so now that I know both of these are perfect cubes, I can start writing out my formula. Okay, so essentially you take the cube root of it, so you'd be left with x plus 5. Because the first one is a plus, that means my next sign is a negative. If you look back up to these equations, there's only one minus in either one of them. So it's either the first or the second. So following this pattern, you have a squared. So that's that first term squared. So in this case, it would be x squared. Then it would be a minus a times b. So these two being multiplied. So if I multiply 5 and x, I get 5x. And then the last one is b squared. So it's my second term squared. And 5 squared is 25. And that's my final answer. So following this pattern on the next one, okay, 8 is really 2 to the third. 27 is really 3 to the third. Okay, so if we were to take the cube root of it, you'd get 2x plus 3. Okay, now do you need to do this step here? No, I'm just showing you where they're coming from. So now we use this part to help me fill out the rest. Okay, the first term comes from squaring 2x. Well, 2x squared would give me 4x squared. The next one comes from multiplying these two things. Well, 2x times 3 is 6x. And that has to be a minus because there's always one minus. And then our last term is 3 squared, which is a positive sign. And that is your final answer. So same thing is happening on 14 and 15. On number 14, though, you notice, hopefully, that there are a couple things wrong. First off, 12 is not a perfect square. And also there's q and q to the fourth. So you might have to factor out a GCF first, and in this case you do. You take out a 12q, and you're left with w to the third minus q to the third. So 12q can stay, but then this part can be factored using the difference of cubes. So this time we take the cubic root, and it is w minus q. Since we've already used the minus, everything else later is going to be a plus. So we square the first one, so it's w squared. Then we multiply those two, which is w times q, which is w cubed. And then we square the last one, which would be q squared. All right, so now we are going to factor polynomials that are in quadratic form, okay? So what's happening here is there just might be one extra step going on, okay? So 16a, all right? If you notice, it's the same as 16b, these two. There's just a minor change. So let's focus on a first. Noticing that it's three terms, we should figure out that we can t-chart it. So first times last gives me 100. And two numbers that multiply to positive 100 and add to negative 29 is negative 25 and 4. Sorry, negative. We put our 1 and our x in our denominator, and we have x minus 25 and x minus 4. The only thing that's different on 16b is when we do our process of t-charting. This time, since this is x to the fourth, that means that we need answers with x squared. So instead of putting 1 in x, we're going to put a 1 in an x squared. Whatever number is in the denominator, or whatever variable is the denominator, should match your middle term. So our middle term is an x squared, so we should have an x squared in the denominator. So now when we write it bottoms up, we have x squared minus 25 and x squared minus 4. And both of these are actually difference of squares. So this gives me x minus 5 and x plus 5. And this gives me x minus 2 and x plus 2. If we look at 17, again, 17a and b are very similar. For a, I don't know how to factor this with an x cubed, so I need to factor out an x. You're left with 3x squared. Oh, sorry, we can factor out more than an x. Let's factor out a 3 as well. So we're left with x squared minus 12x plus 35. And if we t-chart it, we get 35. And we need to add to negative 12, which gives me negative 7 and negative 5. So we put our a value, which is 1, and our middle term, which is x, in the denominator. So we have x minus 7 and x minus 5. Don't forget to drop down your 3x. So on the second one, we would take out a 3x again, because it's the same problem. But this time we're left with x to the fourth minus 12x squared plus 35. So when we create our t-chart, we again would have negative 7 and negative 5, but we would have a 1x squared in the denominator. So we have 3x and then x squared minus 7 and x squared minus 5. And we can't break those ones down because 5 and 7 are not perfect squares. So number 18. I can't take out a GCF, so I'm just going to t-chart it. First times last gives me 8. I need to add to negative 9, between negative 8 and negative 1. Now we put a 2 and an x in the denominator, but it has to be more than just x. It has to be x to the third.